Hello. In this video, I will show you a schematic workflow for machine learning with spatial data. The modeling workflow starts with spatial data. And there are two spatial data types. There are predictors and response data. The predictors are typically raster data, like, for example, environmental temperature or sunshine duration. The response data typically is given by vector data, like the position of landscape elements, for example, trees or houses. In the next step of the modeling workflow, we need to extract the relevant spatial data into a data frame. In this table, all pixels covered by the response data are assigned the value of the predictors at their spatial location. In this example, blue represents the pixel of the blue feature, red represents the pixels of the red feature, and green represents the pixels of the green feature. So we end up with a table in which the rows represent pixels and columns the predictors. The cells of the table are the values of the predictors at the location of each pixel. So note that these values can have different data types, for example, numeric, integer, or categorical. In the next step, we need to decide for a method to calculate the model. Especially the method called random forest has proven to be a fast and efficient method for making area-wide spatial predictions. However, there are plenty of methods around in machine learning, like gradient boosting, support vector machines, maximum entropy, boosted regression trees, and many others. But do not get afraid by the name of these methods. For now, simply remember that they all use such an extracted dataset from spatial data for modeling. In machine learning, in fact, we build not only one model, but many models in an iterative way to come up with one final model. In the case of the random forest method, all these models slightly differ because of random sampling of the rows, indicated in gray here. But also by random or by selection of columns in the dataset. The random sampling of rows can also be used for detecting or for checking the quality of a model, which is called cross-validation. Whereas the selection of columns, in this case, is called feature selection. How random sampling is controlled in cross-validation and feature selection strongly influences the quality of the model and leads to different spatial predictions. So, watch out how random sampling is controlled in your models. Thanks for watching, and see you next time.